Students, so these we are just doing more examples on the circle. So we've not yet introduced the properties of the circle, but we're just dealing with the circle itself and some few terms that we've defined in the former videos related to the circle. So we have our question there: a circle with an arc, then subtending an angle of 60 degrees as at a center, then radius is 7. So our part A of the question, I said it is crucial to know, it is very crucial to know how to define the small things we learned in primary. So our part A is find the area of the circle. So find the area of the circle. Find the area of the circle. So we know that area is given by pi r squared, such that we have this one as 22 out of 7 multiplied by the radius squared, 7 times 7, such that this is in centimeters squared. It regresses to 154 centimeters squared. We have part B. Find the area of the minor sector. Find the area of the minor sector, sector. So what is the minor what is the minor sector here? Remember, the sector is, leave this line alone, the sector is the whole of this portion. That is the minor sector. This other one opposite is the major sector. This one that is subtended by the two radii on the circumference minus this line is what we call a sector, but since it is the small one, it is the minor sector. So if we are to find the area of the minor sector, we are going to have this as area will equal, we get the angle which is the one that it subtends, which I can call theta, divided by 360, then multiplied by area of the circle, which is pi r squared. But we've already calculated the area of the circle, which is 154, meaning the area of the minor sector, I get the angle in the minor region over 360 multiplied by 22 out of 7 multiplied by the radius squared, which is 7 times 7, or simply you get 60 out of 360 multiplied by the area I've already calculated. So if you press your calculator properly, you will produce 25.67, but this is in centimeters squared. Our part C of the same question is you find the area of the major sector. So find the area of the major sector. Allow me just say area of the major sector. And we should economize on your data. Area of the major sector. So still the same thing. The major sector is this opposite part, this one that I'm dotting. This opposite part constitutes of my major sector. So I get this other opposite angle, so which is 360 minus 60, meaning this other opposite angle is 300 degrees. So area of the major sector will equal to the 300 degrees divided by 360 multiplied by the area of the whole circle to get the area of the major sector, but we've calculated this at 154 in centimeters squared. Pressing the calculator properly, if I press the calculator properly, it gives me 128.33 in centimeters squared as my area of the major sector. The next question. So our next question is finding the area of the minor arc AB. So student, the minor arc is this length from here to here. So if we are to find the area of the minor arc, I simply get the angle out of total tan multiplied by the circumference of the whole thing to get the distance from here up to here. Simply this angle that is making this arc divided by the total angles at the point multiplied by the circumference will give me the length of the minor arc. So it is as simple as that. So length of the minor arc AB, so this would equal to, so the angle is 60 divided by 360, but then multiplied by the circumference, which we called 2 pi r, which is 2 multiplied by pi, 22 out of 7, multiplied by r, which is Our R is 7, and this is simply in centimeters, such that if you press your calculator properly, you get 7.33 centimeters. We can trim off to 2 decimal places. Then part D, part E, I think, the length of the major arc. You calculate the length of the major arc of the length of the major arc of length of the major arc. Still the same thing. I get 300 degrees, which is the angle made by the major arc, the bigger arc, divided by 360, multiplied by the circumference, which is 2 pi r, 22 out of 7, multiplied by r7, and this goes to a 36.67 in centimeters. Then so it was as simple. So our next question is to calculate the area of the shaded part. So the shaded part in question was this part. This one was our shaded part. That is our shaded part. So we want the area of this. But then how would I calculate the area of this? I simply get the area of the whole sector, which we've already calculated actually as the area of the minor sector, and then I take off the area of this triangle. So this triangle, I can simplify it, or I can use a half sin 60, but then I can simplify this guy. I divide it here, then I multiply my result by 2. I divide it here, create a right angled triangle, calculate the length of this guy, divide it by 2. Then I use Pythagoras to get the length of this one, and then the length of this, and then this, get the area of this portion, multiply it by 2 for this, then I subtract off from the area of the sector. But mathematically that would be a very long working. So student, what I'm saying is that approach of calculating the length of AB from here to here would be long and hectic. So let us introduce ourselves to a very small formula that we can use to calculate that guy. So if we want the area of the shaded part, area shaded will equal to the area of the sector, then I take off the area of the triangle, but then area of the sector, we've already calculated it. It is 25.67. This is 25.67. Then take off the area of the triangle. A new simple formula will be a half. Then I square the radius, r squared, sine the angle, sine over the angle the triangle is making. So sine of the angle that has been made at the center. So I have 25.67 minus a half radius squared times 7 times sine of 60 degrees, which is root 3 out of 2. If you're lost there, you visit our trigonometry videos. So if you compute this properly and then you get 25 on your scientific calculator minus the whole of this, you will find you are producing a 4.45, because when I press that one on the calculator, I produce close to a 21. Yeah, I produce like a 21.22. Yeah, approximately that 21.22 when I press this button on the calculator minus this, I got 4.45 centimeters squared, because it is area centimeters squared. Yeah, so our next videos, let us look at let us look at other interesting stuff on the circle and its properties.